Okay, picking up with our EOC sample practice assessment, we're at 311. Write an equation of a line that models data sets, uses equations or graph to make predictions, and describes slopes of lines using the data. And don't forget that slope is the rate of change. Rise over run, change in the x's over the difference in the, or difference in the y's over difference in the x's. It's a rate of change. Okay. When we look at this first example here, 1A and 1B both use this graph. Rachel plotted the average cost of a loaf of bread from the year 2000 to 2012 on the scatter plot below and drew a line of best fit. See the scatter plot, different points, and the line of best fit kind of goes through the middle of it. What's the equation of the line that models the cost of the loaf of bread over time? So I can see my y-intercept is 0.9. Okay, and they're all 0.9 here for y-intercepts, my b term. So we got to find the slope between these 2 points. So let's go down here. Let's find the slope. We start off with the point 1 and 0.95, and the other point is 10 and 1.4. So our slope is going to be 1.4 minus 0.95 over, let's see, I'm sorry, that's 4. 10 minus 4. So we're going to get negative 4.5. I'm sorry, positive 4.5. Wrong decimal points in the wrong place. Let's clear that up right there. .44 minus this is going to be 0.45 over 6, and that's going to give us 0.05 for a slope. So we come back over here, 0.05 plus the 0.9. There's our equation right there. Y equals mx plus b. I just slipped in the m right there. Okay, and there's the y-intercept. You can see it there. So your answer is C. Using the same graph here, and again, you should have a copy of this already off of the headline, so you can follow here. You can look at the graph on your paper. If Rachel plotted the average yearly cost of the bread from 2000 to 2012 on the scatter plot, which statement best represents the meaning of the slope as a rate of change for this line of best fit? The slope represents the average cost of the loaf of bread. Not really, each of those points is that cost. The slope represents the average increase. Here's a change right here. And we know it's increasing because the price is going up as we go to the right, as the years go on. So the average increase of the cost per year for the loaf of bread, that's what the line of best fit is showing. Okay, it's not a decrease, and it's not the number of years that it's increased. It's B, represents the average increase in the cost per year. Okay, the rate of change. Problem 2. Water is being added to a swimming pool at a constant rate. The points on the graph below represent the gallons of water in the pool as a function of time. How many gallons per hour are being added to the pool? Rate of change, gallons per hour. So we're looking for the slope here. Okay, it looks like we're in a straight line here. So we can pick, it's a constant rate going into the pool. We just want to know what that rate is. So pick any 2 of these points. Okay, let's come down here. Hey, how we doing, Michael? So I'm going to come over here. I'll pick the first 2 points. So I've got 2 and 1220. And we've got 4 and 1740. So my slope, change in the y's, 1740 minus 1220, all over 4 minus 2. We're going to get, what, 520 over 2. So that's 260 gallons per hour. Okay, 260 gallons per hour. That's my slope. And remember, put it all over the left or all over the right, but just don't write 260 right in the middle. Okay. 3. The graph shows an airplane's altitude during its initial descent and preparing for a landing. At what rate, slope, feet per minute, is the altitude changing? So again here we got a constant descent. So I'm going to get a negative slope. You can see it's going down to the right. So again, I'm going to take two of the points, come down here. I'm going to do the same thing I did up here. Well, I'm going to take the points 2 and 33,000. And then I'm going to take 6 and 31,600. Yep. Let's find the slope here. And the negative will take care of itself here, because 31,600 minus the 33,000, there's your negative right there. 6 minus 2. So we're going to get, what's that? 1,400 all over 4. And 4 is going to go into there. 1,200, that's 350. Okay. 350 times 4 is 1,400. So we're descending. Oh, and again, this was a negative up here, so that's a negative. That's going to be important. So when you put your answer in here, make sure in the one of the boxes, so if we're looking like this, one of the boxes is going to have the negative in it. Okay? Negative 350. All right. Moving on here. Next benchmark, 312, problem 1. Amanda drew a line segment to the right. I'm sorry. Here we're graphing linear equations and inequalities in 2 variables with and without technology. Okay, again, you get a little calculator that comes with this, but it's going to be a 4-function deal, so you're not going to have a graphing calculator. Write the equation from the given graph. So if we drew this line segment here and we want to know the equation of the line, notice everything's in standard form. Okay, notice we know the x and y intercepts, which is how we attacked standard form equations earlier. So I'm going to take the point 0, 9. 0 for x, 9 for y. You can pick either one. And I want to find which one of these works. So when I plug in 0 for x and 9 for y, I'm not going to get 9, so it doesn't work there. 0 here, minus 7 times 9 is 63. I don't get that. 9 times 0 is 0. 7 times 9 is 63. Boom, it's right there at C. Okay, 0, 9 works there. And you can take 7, 0. 9 times 7 is 63 plus 0 is 63. So it's C. It works in both. Okay, so you really don't have to do much there. Just understand that these points are x and y's in the equation. So just plug one of those points in and see which one works for you. Problem 2. The Society of Women Engineers is selling t-shirts and collared shirts at a regional conference. Collared shirts are 12 bucks, t-shirts are 4. The graph below represents the number of shirts they must sell before making a profit. This is the break-even line right here. Okay, so let's take a look here. We're all in y equals mx plus b form. I see my y-intercept is 30. All of these are 30, so that doesn't narrow it down at all. So I also know I'm graphing up, and I got a dashed line. So I'm going to get y is greater than. Okay, that's a y is greater, that's a y is greater. So it's probably between these two. All right, so let's find our slope right here. We've got 0, 30, and 90, 0. So kind of like what we were doing down here. Let's get rid of all of this. So 0, 30, and 90, 0. Our slope's going to be 0 minus 30 and 90 minus 0. So negative 30 over 90 is negative 1/3. So there's my slope, and there it is right there, negative 1/3 x plus the 30 for my y-intercept. So my answer there is A. And the third problem here, last one we'll do in this section, which is the graph of the inequality 3x minus 5y is less than or equal to 30. Let's just graph it on our own first and see what it looks like. Okay. So I start off here 3x minus 5y less than or equal to 30. When we're graphing, we've always changed everything back into y equals mx plus b. Okay, that just seemed to work better for us. It was just one way we could always do it. Okay, you can't actually combine those. I'm going to divide by a negative, and this is another reason why I want to show this. I've got to flip my inequality symbol because I divided by a negative. So it's greater than or equal to positive 3/5 x minus 6. So y equals 3/5 x minus 6. So I got a y-intercept of negative 6. And I look here, that one's got a y-intercept of negative 6. That one doesn't. That one doesn't. This one does. Okay? But I notice here, when I look at slopes, okay, this one up 6 over 10, there's 3/5. Up 6 over 10, that's 3/5. But this one is shaded up. Okay? So this is the one we're looking for. Remember over here, y is greater than or equal to. This is greater than or equal to. This one over here is less than. Okay, so that one's not going to get it. So the answer here is D. Okay? So slope-intercept form, then look at the graph. A lot of times, too, you can plug in points and figure it out, too. Any of the different variations we've been doing, x and y intercepts, I just showed you something a little different here because we actually dealt with the graph, and we like y equals mx plus b with that. Okay? All right, hopefully this has been helpful. We'll pick up on 313 on the next one.